Hello class, and welcome to your new unit. This unit is on arithmetic and geometric sequences and series. Our first lesson is lesson 9-2 out of the textbook, and the title is Arithmetic Sequences. We've got learning targets. I can identify an arithmetic sequence, and I can find missing terms from an arithmetic sequence using the formula. So we first are going to have to talk about what arithmetic sequences are, and then we're going to learn how to do all kinds of fun things with them. So stay tuned, here we go. So a sequence in general terms is just an ordered list of numbers. So some list of numbers in a specific type of order. An arithmetic sequence, which is what we're studying in this lesson, is a sequence with a constant difference between consecutive terms. Or in other words, it's a sequence of numbers where we can find that we keep adding the same number over and over and over to get the next term. The common difference is the difference between the consecutive terms of an arithmetic sequence. So that's the number that we're going to add over and over and over to get the next term. So if we take a look at these first examples, the directions say to find the next four terms of each arithmetic sequence. So first of all, let's take a look at the numbers that we have here. We go from 91 to 83, and I notice that is decreasing. So that's equivalent to adding a negative number. And then 83 down to 75. So what is that number that we're adding? Well, we can find that by saying 83 minus 91, and we get negative 8. Also, 75 minus 83, and again we get negative 8. Negative 8 is the number that we would call the common difference. That's the number that we're adding over and over and over to get the next term of the sequence. These are the terms of the arithmetic sequence. Okay, so I'm going to go ahead and extend this to get the next four terms. So 75 plus negative 8 is 67, and 67 plus negative 8 is 59, and 59 plus negative 8 is 51, and 51 plus negative 8 is 43. So those are the next four terms of the sequence. And looking at the next example, 34, 40, 46, I can look at that really quickly and know that those numbers are increasing by 6. So the next four terms, I'm just going to find by adding 6. So 46 plus 6 is 52, plus 6 is 58, plus 6 is 64, plus 6 is 70. The third example may be a little difficult for you to understand because we see some mixed numbers and fractions. So if you're working on a calculator, just a regular calculator that's non-graphing, that doesn't allow you to type fractions in easily, we could convert these to decimals and look at it more carefully. So if I just take the 1/2 and do 1 divided by 2, I can convert that to the decimal 0.5. And 1 1/8, well, if I just divide 1 divided by 8, I get 0.125. So this is 1.125. And 1 3/4, that's 1.75. So if you look at it with the decimals, maybe that's a little bit friendlier. And it is okay to go ahead and extend this with decimals. So by subtracting the consecutive terms, I find the difference between the terms is 0.625. Now, as a fraction, that is 5/8. So we're adding 5/8 over and over, or we could say we're adding 0.625. So if we continue by adding 0.625, we're going to get 2 point. So if I have extended this here and I've given you the decimals, if we've added 0.625 to the first three terms that were given to us, add 0.625, I've got the decimals that you see here. And then if we take those decimals and we convert them to fractions, we get these values here. I can convert these decimals very easily to fractions on the calculator. I just took the decimal part, 0.375, and I typed that in. And then push math, enter to convert that to a fraction that converts to 3/8.
If we look at problems 4 and 5, we'll see that these are two different ways of looking at an arithmetic sequence. It's called AN is equal to 3n minus 2. So it's this lovely little equation here, 3n minus 2. But this isn't what we call a linear equation because the exponent is only to the first power. And linear equations we can or are a way of expressing an arithmetic sequence. So I could find 4 terms by substituting in the numbers 1, 2, 3, and 4 into the equation. So for example, to find the first term, A1, I would substitute a 1 in place of the n. So 3 times 1 minus 2 is going to equal 1. So the first term of my sequence would be 1. To find the second term of the sequence, I would substitute in a 2. 3 times 2 minus 2, that would be 4. To find the third term of the sequence, I would substitute in a 3. 3 times 3 minus 2 would be 7. And to find the fourth term of the sequence, I would substitute in 4. 3 times 4 minus 2 is 10. So if I just take a look at these numbers that I got, A1 was 1, A2 was 4, A3 was 7, A4 was 10, you should notice an arithmetic pattern. If I add 3 to 1, I get 4. If I add 3 to 4, I get 7. If I add 3 to 7, I get 10. So this is an arithmetic sequence of terms where the common difference is 3. We keep adding 3 each time. Also notice that 3 is the number I'm adding, but it's also the number that was being multiplied by n, and that is not a coincidence. So let's take a look at the fifth example. We've got 12n plus 3. Let's find A1, A2, A3, and A4. Go ahead and pause the video and see if you can find A1, A2, A3, and A4 exactly like I did. So I found A1, A2, A3, and A4 to be 15, 27, 39, and 51. And if you look at the difference between these, 15, you have to add 12 to it to get 27, and 27 plus 12 is 39, and 39 plus 12 is 51. So the common difference is 12, and that happened to be the number being multiplied by n here. So we start to see some patterns here. So there is a formula for the arithmetic sequence. The nth term of an arithmetic sequence with the first term A1 always stands for the first term of the sequence, and a common difference is D, is given by this formula. AN is equal to A1 plus n minus 1 times D, the common difference, where n has to be a positive integer, or we're talking about maybe the 10th term or the 5th term or the 4th term of a sequence. In these examples, we're asked to find the nth term of each arithmetic sequence. So I'm going to start by writing down the formula. And now I'm going to substitute the values that were given into this formula. So here I'm looking for the 10th term of the sequence that starts with 4. 4 is the first term. And we're looking for the 10th term, so we substitute that in for n, where the common difference is 5. Now I could just create the sequence on the side. If the first term is 4 and the common difference is 5, I know the next term would be 9. And then 14, etc. I could just find it. But what if I had been looking for the 100th term of the sequence? This formula sure does make it easier. So if I substitute my values and then simplify the expression, I'm going to have 4 plus 9 times 5. And I know that 9 times 5 is 45. And 45 plus 4 makes the 10th term 4 plus the 45 that I get here is 49. So very quickly I can find that the 10th term of this sequence is 49. In the second example, it tells me that A1 is 33. And it tells me my common difference is negative 7. So 33 plus negative 7 is 26. So that's going to be the second term. And then plus negative 7, the third term would be 19. And we could continue that. We're supposed to find the 128th term this time. I most certainly would not want to extend that pattern till I have 128 terms. So this is why the formula is so powerful. So let's write down the formula, substitute, and find that 128th term. I want you to notice that when I substituted here, when I substituted for the common difference, D, since it was a negative number, I enclosed that in parentheses, and that's going to help me remember that I am multiplying these two quantities. I am not subtracting. So I put those parentheses there to help me remember to multiply. So I'm going to find that 128 minus 1 is 127. So we have 33 plus the quantity 127 times negative 7. So now I'm going to multiply 127 times negative 7, which gives me 33 plus negative 889, and then add to that the 33. So I get negative 856. So the 128th term, I could say A128 is equal to negative 856. And the last example is asking me if the first term is 2 and the common difference is 10, find the 403rd term of the arithmetic sequence. So using the formula, AN equals A1 plus N minus 1 times D, I'm going to substitute to find the 403rd term. So here I've substituted. That's going to give me 2 plus 402 times 10. So 402 times 10 is 4,020. Add 4 to that, and I get that the 403rd term of this arithmetic sequence is 4,024. Now it just gives me a sequence 4, 10, 16, and I'm supposed to come up with what's the 14th term for this given sequence. I could extend the sequence, but we don't want to have to always rely on that because it may ask me not to find the 14th, but to find the 140th term. So I need to be able to use this formula. So I'm going to substitute into the formula. It's wanting me to find the 14th term. So now I'm looking for A14. And I notice that my first term given here is 4. I'm going to substitute that in place of A1. I know that I'm looking for the 14th term, so that's my N. And my common difference, I'm just going to find by subtracting here. 16 minus 10, that's 6. 10 minus 4, that's 6. So the common difference is 6. And this is how I'm going to find the 14th term very quickly. So here I notice that I'm going to have 14 minus 1, which is 13. I'll be multiplying 13 by 6 to get 78. So I'll be taking 4 plus 78 to give me a 14th term of 82. The last example asks us to find the 34th term. Find the 34th term of the sequence where A1 is going to be 0. And this time, what's the common difference? Well, this time we're not increasing. We seem to be going further and further into the negative. So we're adding negative 3. So negative 3 is D. A1 is 0. D is negative 3. And we're looking for the 34th term. I want you to try to come up with the answer for the 34th term on your notes and bring it to class with the correct answer for the 34th term. Good luck, and I'll see you in class.